So, today we're going to be doing a fairly simple introduction to functions of families. I think I said functions of families, and I'm not sure why I put an of in there. Families of functions. That makes more sense. But we're talking about function families. So, first off, when we talk about functions, they're generally defined as each input has exactly one output. It talks about equations or graphs, or sometimes it comes out as a table. The key thing is what goes in can only have one possibility of where it goes out. I can't put 3 into an equation and have it come out with both 5 and 7. That wouldn't work out. It comes out with a singular number, regardless of how many times you put that same number in. Now, function families essentially is talking about the different types of functions that exist. And you have talked about a lot of different functions through your math so far. The most common one that we come across is linear functions. Does that word sound familiar? Do you remember what linear equations look like? That's not linear, that's just basic arithmetic. Linear functions often start with y equals or f of x equals. I'm using f of x because that's function notation, but I could just have written y equals. What's the first thing that comes to mind after someone says y equals? Okay. What if it wasn't just a number? What if there were letters involved? X plus something. That's a linear function. Y equals mx plus b, ring a bell? Any function that fits this format is a linear function. Key thing about this format. First off, there are 2 variables involved. Most functions have 2 variables involved in them. Oftentimes, they are x and y. Y'all see the y here? F of x is a fancy way of writing y. It's function notation. It literally means the output of a function, which the output's generally y. Function notation gets a little bit more specific because function notation allows me to write things like this. F of 6 equals 8, which tells me that the function has an input of 6 when it has an output of 8. In other words, it hits the coordinate point 6, 8. That's why function notation is created, is it allows us to see this. It also allows us to differentiate between that function and this function, because you call one of them f of x, the other one g of x. Both of them will hit the point 6, 8, but they're 2 different equations. They're both linear because they have those 2 variables, but specifically, it's 2 variables and there's no exponents involved. if you're wondering about the M and the B, those are just placeholders for numbers. Now if I draw a graph, does anyone remember what a linear graph looks like?
Straight line.
Yes, straight line. Now, technically there's a little bit more pickiness to it. It is a straight line. Specifically, it is a straight diagonal line. The moment that it is vertical or horizontal, it is no longer a linear function. If it is vertical, it's not a function at all. If it is horizontal, it fits under a different family. Speaking of which, that next family is known as the constant functions. The constant functions is the oddball of the group. It's one that doesn't have two variables. Constants always have one variable. That variable being that f of x. F of x being a fancy way to say which variable? Y. It's generally just y equals a number. It's called the constant function because it is constant. It's not changing. Variable means changing. We put letters as our variables to take place of numbers because we don't know what those numbers are at any given time. Constant functions are horizontal lines. Next family we're talking about is the quadratic family. Quadratics are, other than linear, they're the most common function that you've talked about previous to this class. They're in the form of f of x equals ax squared plus bx plus c. We're going to see a lot about quadratics in this class again. We're going to see some linear. Most of your linear stuff you've done prior, though. We're going to see quite a bit of quadratic. Again, quadratics are two variable equations. They've got that f of x or y, and they've got x. A, b, and c are placeholders for numbers. You're never going to be given a function that a, b, and c are not just straight up numbers. Quadratic means it's going to contain an x squared. And no higher or no other exponents. Does anyone remember what quadratic equation graphs look like? I have no clue what you said. Just say a little louder.
Curved upward.
Curves upwards. I will agree with that. Need a little bit more to it though, because there's a lot of graphs that curve upwards.
Rattle up.
It's known as a parabola. It curves upwards on one side, on two sides.
Both
Yeah.
sides.
Yeah, because it's a U shape. So it does curve upwards. I was just wanting a little more specific. But yeah, it's a U shape. Technical name is a parabola. In Algebra 2, we also deal with exponential functions in the form of f of x equals a times b to the power of x. A and b, again, placeholders. Because, just like the others, exponential functions have two variables. Specifically, it will have a number to the power of a variable, mostly x. It's called exponential because you will find the variable in the exponent. I'm going to draw two separate graphs for this one just because people tend to miss out on the second one. Oftentimes with exponential, we talk about exponential growth, exponential decay. Something grows exponentially. When something grows exponentially, do you know what that means?
It grows it grows at a consistently larger rate every time.
Yeah, it's getting bigger and bigger and bigger, faster and faster and faster.
It's like acceleration. Like
I understand what you're saying.
it's accelerating in its growth.
Yeah, because it's getting bigger, faster. Okay, I'm following you. So, exponential growth looks something like this. But there's not only exponential growth, there's exponential
Decay,
decay.
as you mentioned.
Yep. Key thing about exponential graphs. They have a part that flattens out almost. And that is not a technical term. Nor does it get perfectly flat. It just kind of goes flat-ish because there's asymptotes involved. And it tends to do this both vertically on one side and horizontally on another. Again, never perfectly flattens out. But it kinda does.
It just gets to the point where the changes is so small or large that
You don't tend to notice it.
that you can't notice it.
Exactly. Okay, there's two other families we're talking about today. Can I fit them on this page? Maybe. There's the radical family. Now, radical family is actually a very, very, very large family. It can be broken down into smaller families. The most common family that we see is the square root family. Going to have two variables. Generally, you're going to have a square root with the variable inside of it. I'm going
going to switch my graphs a little bit to get them to kind of fit on this page because I don't really want to move to a second page for the different types. Radical graph generally looks something like this. It's got a starting point. And then it kind of curves to the right. There are very few instances where it will curve off to the left. We're just not going to talk about them because 99.9% of the time, there's no real application of that. Gesundheit. I'm going to right over the bottom of this. Last family that we're talking about is absolute value. Absolute value family, 2 variables. And you're going to have an absolute value symbol around the variable. So do you remember what an absolute value graph looks like? This is one that's hit or miss on if people remember it. Typically when I show you, a lot of people are like, oh yeah. But no one tends to come up with it off the top of their head. Remember the V-looking graphs? That's an absolute value graph. Looks like a V. Could go upwards, could go downwards. Same with the parabolas. Could go upwards, could go downwards. That's a matter of some reflections happening. That's generally what you're going to see. Okay, the practice for today, the purpose of today is, can you recognize the family? So, what you're going to see today on your assignment is going to look something like this. It's going to ask you to identify the family. And then with that, it could do something like this. It might give you a graph and do something like that. Which family do the graphs look like that? Quadratic. Ta-da, you've answered the question. Or maybe it'll do this. It might give you the equation and ask you which family fits that type of equation. Exponential, because where's the variable? In the exponent. Variable's up here, exponential. Constant. Only one variable. Easy enough. A lot of it's just giving you a lot of information. But for the most part, what I'm actually asking you to do today is just recognize the family.